What's up, people? Welcome. How are you guys doing? That was a sudden this thing. I wasn't expecting it to be live so soon. What's up? How y'all doing? I'm 1 minute early today. What's up, people? How's everyone? Hi, Arkita. Hi, Abhinav. Hi, Divyesh. Welcome. Can you guys all hear me and see me, people? All good? Good afternoon, guys. Good afternoon, Devida. Hi, Hadi. What's up? Hi, Artika. What's up? Welcome. Hi, Aparna. Welcome to the session. What's up, people? How am I? I am not doing so bad. How are you guys doing? Hi, Bhargavi. Hi, Gaming with Vansh. Hi, Abhinav. Welcome. Namaste to you too. Make a video on 11th transition for sure. Shubham. Why not? Why not? All good, Skanda. How are you doing? Good afternoon, Smith. Welcome, people. Hi, Anushi. Hi, Bhargavi. Hi, Fike. Welcome, guys. Oh my God, what's up? What's up? Sorry, Devapita. I've been feeling sick for the past 2 days again. That's why I'm really sorry, guys. I'm really sorry. I have been lacking behind on replying emails for a past couple of days now. I will get to it. I'm just not feeling so great. That's why. I am not doing so bad. I mean, recovering, but few days, it goes bad, and few days it's good. So, anyways, welcome back, people. Hopefully, I did have my lunch. What about you guys? Did you guys also have your lunch? I hope that you did. So, anyways, welcome to the session. My name is Mr. Batman. aka Mr. Anoop. Welcome to the session. So yes, people, today is going to be our day where we're going to be talking about black holes. So the question that we're going to answer today is this: do black holes really exist? And this is a series that has been going on for a long time now, where we'll be talking about few phenomena that's there outside CBSE textbooks in your related to space and stuff. That's what we're doing. So very warm welcome, and this by far is, I feel like, is the most coolest thumbnail there is. It reminds me of that filter, that Instagram wala filter, that double filter. I know how they do it. I have one picture and they're using that same picture for every single thumbnail, and I don't know how they make it look cool every single time. So yeah, kudos to the YouTube team. Anyways, welcome, guys. Welcome. Good afternoon. Welcome, guys. Welcome. Hi, Emandri. What's up? So yo, people, today I don't think we'll have any mentee per se now, because this is just a generic topic, so there's no mentee as such. But yes, trust me, guys, the topic is going to be super interesting, because it's not something that you listen every day, right? It's not your regular reflection, refraction, electricity, current. No, it's black hole, and everyone likes talking about this. So yes, let's talk about that. All right, so people, shall we begin? Yes, Himadriji, what's up? Hi Prathamesh, hi Swayam, what's up? Yes, let's start. Alright, people, that's it. Let's begin then. So yes, guys, welcome to the session once again, and we shall begin. Alright, so what is a black hole? And do black holes really exist? Let's answer these questions. Alright, let's do it. Now everyone, listen up carefully. Now to answer this question, guys, is do black holes really exist? The answer, I'll tell you right away. Surprise, yes, it does exist. We have already captured the first ever picture of a black hole in 2019 as well. So it's very clear that black holes do exist. But the question that we're trying to answer is, what exactly is a black hole? What is a black hole? And how is it there? Like, why is it there? What exactly is it? What makes it so very special? That is what we're going to talk about. So let's start with the definition, right? So what is a black hole? How do you define a black hole? Anyone in the chat box would like to take a gander, or would like to take a shot at it? Like, if I were to ask you this question, what is a black hole? What would you say? A hole which is black? A hole which is not any other color? A hole, or a tiny a tiny gap in between? What exactly is a black hole? What is the thing that comes into your mind? Tell me, people. Snoop and Baba itself. Sure, Naman, sure. Hi, Bhargavi. Yes. Can't explain. Oh, all right, Arkita. Anyways, so according to simple, if I have to explain it in a simple manner, black hole is nothing but a region in space where the gravitational force is so very high that not even light can escape. So black hole is not some hole in a wall. No, that is not what black hole. Black hole is a region where the gravitational force makes it impossible for anything, not even light, to escape. Only if light is getting reflected back, that is when you'll be able to see a different color. And black is that object where light is not getting reflected at all. So the reason why it's called as a black hole is because light is not getting reflected, and it basically looks like a big circle. That's why it is basically called as a black hole. So yes guys, how does a black hole formation happen, or what helps the formation of a black hole to happen? Anyone knows what is the reason for this? Anyone who likes to egg are Disney life awesome, like exactly. Anyone else who knows the answer for this question, like why, how does a black hole come into existence? Is it just that one day it's not there and the next day it comes into existence? What exactly is the reason that a black hole comes into existence? Like how does it happen? Like out of nowhere, or is it a long process? Finally, it comes into exactly, guys. See, people, in our universe out there are billions of stars, right? Our sun is a very average size star. It's not big, it's not massive, it's just an average star, right? It's just an average star. But there are stars out there which are massive stars, like for example, the UY Scuti, which is the largest star that we know of, right? And this star is massive. When I say massive, it's like maybe 30 times the diameter of the sun, or 120 times the diameter of our sun. So you can basically fit in about 120 sun in the diameter of those kind of stars. So it's basically massive. And when these kind of massive stars die, when they come to an end, when their lifeline ends, what happens is this, people, towards the end of their lifeline, towards the end of their life, either they will become a black hole or what is known as a neutron star. So if you have to talk about the lifeline, how does it really happen, is basically this. So you have a massive star, it lives for a couple of billion years, and then when the star is about to die, it will become something called as a red supergiant. So what will happen is that this star will now swell up 20 times its size. Then we have something called as the supernova. From the supernova, then you have what is called as a black hole. So black hole basically exists because of stars. So when a star dies, that's how a black hole comes into existence. It is not that someone basically drills a hole in the middle of the universe. It doesn't work like that. It is basically because of the star itself. So the gravitational force, because of these gas particles, because of the mass, is so very high that everything that is there, basically everything gets collapsed inside. Because of its own gravity, everything gets pulled inwards, creating what is known as this beautiful structure called as a black hole. Got it, people? Yes, exactly. That's a star dies like everything else does. So basically what happens is that your sun, like for example our sun has hydrogen in it. Hydrogen is the major is the gas that is present in majority. This hydrogen atoms basically combine together to form helium, and when this happens, that is what produces heat and light. So when all of the hydrogen gas is used up, then what will happen is that the helium gas that is there, that will start to burn up, especially from the outer surface. That is what creates the supermassive the red giant or the super red giant. Once that happens, then all that energy is basically released out in the form of supernova. Then it either becomes a neutron star or it becomes a black hole. So again, everything in nature has its own path. This path of a star is basically like this. So when the fuel is nothing but hydrogen gas. So once that is over, then the helium gas basically starts to burn up. Once that is also over, then the stars slowly start to deteriorate. Finally it completely vanishes off. Now yes guys, like I told you already, black holes, from a black hole, the gravitational force is so high that not even light can escape. And we know that light is the fastest thing, right? As far as humans are concerned, light is the only thing that can travel at a speed of 3 into 10 to the power of 8 meter per second. Nothing can come to the speed of light, or even close to the speed of light, because it's that very fast. But here's the thing guys, throughout the journey of this star's life, whatever gravitational force is applied inwards, because gravitational force is always acting towards the center, right? So whatever the gravitational force is applied or is acted upon, or is present on this, or is pulling this particles, the gas particles towards the center of this of the star, there is equal amount of pressure by the fuel particles, by the gas particles, acting in the opposite direction. So there's an equal and opposite force as well. So because of this, guys, the stars don't exactly collapse when it's normal, when it has enough fuel. It does not collapse on its own, because there is gravitational force, yes, but at the same time there's equal and opposite force that is acting in the opposite direction, which is the pressure, which would basically make sure that the star does not collapse. But then once the fuel is, it's actually a very long process. In fact, it takes billions of years for a black hole to be formed, for a star to die and form a black hole, and it takes another couple of years, couple of billion years, for this black hole also to come out, basically stop existing. Because when this black hole is about to die, it releases all this energy, all the mass that it has, all that radiation is released in the form of Hawking's radiation, and finally the black hole ceases to exist. So that's how that's how it really works. Now, like I told you guys, the gravitational force in a black hole is very high, but I haven't told you by how much, right? If I have to compare it, for example, guys, let's say there's a person who weighs about 100 pounds on Earth. So 100 pounds is like around 45 kgs. Now, if you go on to the surface of the moon, that will be around 1 ton. That's around 907, 906 kgs. That's how much the weight would be on the surface of the sun. If you go to the white dwarf is another, again, when our star is about to come to an end, it will become what is called as a white dwarf. So if you were to stand on a white dwarf, the weight of a person would be around 10,000 tons. So that's how much amount of gravitational force is there on a white dwarf. If you go to a neutron star, that will be around 10 billion tons. And if you go to a black hole, that is 30 billion tons. Where is 100 pounds and where is 30 billion tons? So there's a massive difference. You can clearly see that the gravitational force of a black hole is much greater in comparison to anything that we know of. And that is why, guys, because of this gravitational force, nothing can really escape it. Now, here's the thing, guys. Theoretically speaking, a black hole actually looks something like this. So inside the black hole, basically you have something called as a singularity. So what happens is that this is the black hole, everything ends up into, or basically all of this mass is concentrated at a single point called as the singularity. So this is why. So it's a very small, the volume is less, but the mass of this space is very high, which is what creates the bending of space-time, creating this massive gravitational pull. Alright guys, so yeah, that is how the black holes exist, and this is how, again, we have never been to a black hole. Let me tell you that much. We have never been to a black hole. We would not know what would happen if you were to go to a black hole. But as far as we know, as far as what we have learned, because of the gravitational pull, anything that enters into what is known as the event horizon. So there are several regions inside a black hole. You have something called as a photosphere, where you can see the light. Then you have something called as the event horizon. So that is basically a region which is called as a region of no return. Once you enter into the event horizon, nothing can come back. Now here's the thing, guys. Everyone has this misconception that black hole sucks everything inside. But the fact is, it is not. Black hole does not suck everything inside just like that. No, only if an object enters into the event horizon, it does not go back. Yes, gravitational force is high, it tries to pull it closer, but again, it's like this, remember this, like, see, the sun is a massive object. The sun is applying gravitational force on the earth. Earth is also applying a gravitational force on the sun as well, right? Because of the centripetal force, the earth will continue to rotate in its orbit. So it's not that anything that is close to the black hole just gets sucked in just like that. It does not happen. It doesn't happen that way. Once it enters into the event horizon, that is where you say that it's a point of no return, where you cannot escape from the black hole anymore. Alright guys, and that is what is a black hole. So yes, people, now you can ask me whatever doubts you have. That is all I had to teach. That was a very short session. Every time, I don't know what happens there. Every time I want to read your chats, when I look at the chats, I get all scared. I'm like, what and all are you guys talking? So then I continue with the topic. But nonetheless, guys, if you have any doubts, people, let me know right now. So that was pretty much it. And yes, guys, one more interesting fact I would like to give you guys is this, that that the first ever photo of a black hole was taken up in 2019, and it was named as Pawihi. Pawihi is the first ever black hole that was ever discovered. So yeah, that is also one more information I would like to give you guys. Yeah, so now black hole gravitation is very high. Yes, exactly correct, Sabia. Like I just told you, a person who weighs just 100 pounds on a black hole, his weight would be around 30 billion tons. So there's a lot of difference. So much gravitational force is acting on your body, when you're in a black hole. Hi Shweta, what's up? So what is the relationship between gravity and light? Artika, see, here's the thing. Again, according to Einstein's theory, if you talk about Einstein's theory, what happens is that light, we know that light can be considered as a wave, or it can also be considered as particle, right? When you say particle, it's nothing but the photons. So according to Einstein's theory of gravitation, gravity is nothing but what to say, it's a bend in the space time. Now what do I mean by that? Imagine this is space. Imagine this is space. All right, imagine, I'm just giving you an example. So imagine this is space. All right, it's a very stretched sheet. It's a very stretched sheet. All right, so imagine there's a planet, or let's say there's a black hole. All right, there's a black hole. Now this black hole, because of its mass, would create what is called as a bend. So it will basically bend the space and time, right? It will basically create this bend. So what happens is that when there is a bend in space-time, anything that is coming near to it will basically go, in a form of a whirlpool and finally end up into the center, which is nothing but the singularity. So even light, when you consider light as a particle, that is, when you consider a light as packets of energy, photons, so light would also bend because of this gravitational force, and basically get into basically it'll just get into the singularity and never return. That's what it is. All right, so this is the basic relationship, and this is the reason why you're able to see the black hole also, because you're able to see the black hole as when you just look at it. I'll just show you a picture of it. You see this? So this is where you can see. After this you cannot. So you see this light is actually bending around. So because of the gravitational force, the light is actually going in the form of a whirlpool and moving around the black hole. And once it enters into the event horizon, there's no coming back. There's no reflection happening. So you're not able to see it at all after that. All right. Okay. Anything else, Da? So is there any difference is there any time difference in black hole? Definitely, definitely. So basically it is said that if you go to the middle of a black hole, time literally stops still, because the gravitational force is so high. You see, here's the thing, I'll just give you a simple example. Time, when the gravitational force is high, for example, I'll give you an example. For example, there was this experiment done where we took four atomic clocks. All right, we took four atomic clocks and basically made them all sync with each other. They were all synchronous. So one of the clocks was kept on the Earth's surface, one was on a plane which was made to go around the Earth's surface, and one was on the International Space Station. So basically there were three, right? Now here's what happened, guys. So when they came back after a couple of months, when they came back and checked the time in all the three, because when they were sent, they were all synchronous. They were all in sync. But when they came back, you saw that time was not in sync anymore. So the one on planet Earth was actually moving much more slower in comparison to the clock that was there in the airplane as well as in the International Space Station. So as you go further and further away, as the gravitational force decreases, time actually speeds up. So the time is actually much more faster. So since black hole has very high gravitation, if you go to the center of a black hole, since the gravitational force is so high, it is said that literally time would stand still. Again, it's a theory because we've never done one before. We've never had this experiment. We have never been to a black hole. Again, theoretically speaking, time would stand still. All right. Anyways, yeah. Yes, they will tell me now. Exactly. So if we whirlpool around the black hole, our weight is same or not? Definitely not the same now, because as you go nearer and nearer, your weight is also increasing, because again, weight is what? Weight is nothing but mass into acceleration due to gravity. So because the gravitational force is high, the acceleration due to gravity is also increasing, and so as you go closer and closer, the acceleration due to gravity is increasing, and hence your weight is also increasing. All right. Somewhere that sun does not have capability to turn into a black even. No, it cannot. It cannot. Our sun is too small to become a black hole. Our sun, like I told you, that's how I started the session also. I told you that our sun is it's an average star. For a black hole to be formed, you need a massive star, like UY Scuti. UY Scuti is one of the biggest stars that we know of. So UY Scuti. So UY Scuti is one of the biggest stars that we know of. So UY Scuti, a star like that, could possibly become a black hole in a couple of billion years from now. But our sun can never become a black hole because it's a very tiny star. It's an average star. So it does not have enough mass to turn into a black hole ever. All right. String theory, supersymmetry for interesting. Yes. String theory is definitely interesting, but it's also a little hard to understand. So does our weight and in different planets? Yes. It is. Yes, Barbie. In different planets, our weight is also different because weight depends on acceleration to gravity, mass into acceleration to gravity, and acceleration to gravity of a planet. Remember the formula that you studied. It's nothing but g into m by r square, right? Mass of the planet divided by the radius of the planet, the square of the radius of the planet. So for every planet, the mass is different, the radius is also different. So acceleration to gravity is different, so the weight would also be different. All right. All right. Okay. Yes. Yeah. Anything else? Anything else? So two black holes hit and white hole, no doubt. So if two black hole basically meet, if that ever happens, then it is said that it could either one could be in clockwise and the other could be anti-clockwise. That could lead to what to say, it basically destroying each other and creating Hawking's radiation. So all that mass would be released in the form of radiation known as Hawking's radiation. Otherwise, the bigger black hole could engulf the smaller black hole. That is also a possibility. Either the bigger black hole would engulf the smaller black hole. Otherwise, basically, once they meet each other, they could destroy each other, creating what is known as Hawking's radiation. So Hawking radiation is nothing but the end of a black hole. So when a black hole comes to an end, all that mass, all that energy that is there is released in the form of radiation known as Hawking's radiation, named after Stephen Hawking. Yeah. Do wormholes exist? Theoretically, yes, but practically we have never found one. Alright, what is the difference between a white hole and a black hole? White hole is basically the opposite of a black hole. Into a black hole, anything can enter into a black hole, nothing can enter into a black hole, but everything would leave out of a black hole. So theoretically speaking, white hole is where all the things that enters into the black hole comes out of the white hole. Theoretically speaking. So basically, theoretically, I think I showed you this in the last session also. Theoretically speaking, it would look something like this. So if this is the black hole, anything would enter through the black hole and leave out through the white holes. But then again, white hole does not exist. As of now, we have never found any theory. Theoretically, it is there. It does exist, but we've never found any proof so far. All right. What is the other side of the black hole? Again, see. This is what a black hole looks like. So every black hole basically ends up into what is known as a singularity. So all of that basically gets focused into a single point called as a singularity. So there's no other side to it. There's no other side to it. Again, this is one theory. Another theory is that you could have a white hole at the end of it. But again, in order to really check it, we would have to go and visit it, which we have never done so far. All right. Alright, anything else, Dad? Do we have pulsating black holes? That could also be a possibility. We have miniature black holes. Again, theoretically speaking, when the Big Bang happened, we had lots of miniature black holes also created, and miniature black holes are so small that it's the diameter could be as small as 1 millimeter or even 1 centimeter. So that's how tiny a black hole could also be. But we have never discovered one yet. But yeah, theoretically speaking, miniature black holes also exist. All right. So yeah, pulsating black holes can also be a possible, what to say, it could also happen. It could also be that. So what happens when our sun comes close to a black hole? Our sun would never come to a black hole because our sun, our solar system or our galaxy, to talk about the Milky Way galaxy itself, if you talk about our solar system, it's quite far away from the nearest massive star also. UY Scuti is the nearest massive star that we have. That is also billions and billions of kilometers away. So our sun, our planet or our universe or our solar system would never come into a black hole, would never come across the path of a black hole, at least for the next couple of billion years. We would say, once, because you know that even our galaxy is also moving. Milky Way galaxy is also revolving around something. It is also moving in a spiral direction. Maybe then something could change, but for now, it is not the case. That would never happen. All right. So the particle-antiparticle QFT causing Hawking's radiation is useful mathematical calculation for entropy. Oh yes. All right. So far, astronomers have identified three types of black holes: stellar black holes, supermassive, exactly, intermediate black holes. Yeah. Again, theoretically, we might have pulsating black holes also, but again, we have never found one. We have only found one black hole so far, and that was not also, it was not a supermassive black hole as well. It was, what to say? You can call that as a stellar black hole, but it was not a supermassive black hole. That was the only theory. That was the only fact that we have found so far. Proportional displacement of free vibration. Of free vibration. All right. What is proportional to displacement of free vibration? All right. There with the I'll show that to you. I'll show that to you. I'll show the I'll show the what to say derivation. Just send me the mail. Just send me the mail. I know that I've been telling. I'll reply. I'll reply. Like I told you guys, I'm not feeling so well. Now, as many of you guys know, I'm still positive. I'm still COVID positive. So there are days that I feel good and there are days that I don't feel good. For the past 2 days, again, I've started feeling a little sick. So once I feel a little better, for sure, I would reply to all your mails. And you know that I would definitely reply to all your mails. It's just that right now I'm not in the physical condition to do so, because by the time all my sessions are done, by the time it's 10, all I want to do is just go and hit the bed, because I'll be that exhausted. Interstellar. What about the theory used in Interstellar? That's towards the end it was. It is a possibility. If you talk about string theory, it is a possibility. If you talk about the ending of string theory, of Interstellar, where he tries to communicate using gravity into another dimension, that is, according to string theory, that is possible. So according to string theory, every even time is a dimension. Even gravity is a dimension. So yeah, according to string theory, it could be possible. That's what they've shown in the form of those strings. So they are talking about string theory with that. That is, again, it's string theory, as it's a conflating theory. String theory is something which has been going back and forth. People have there are a lot of pros to it, but at the same time there are a lot of things that that can't be proved as well. So it's a theory that goes back and forth. So until we get something definite, these are all just it'll be just a fiction until we can until we can just finalize it. Yeah, Vishti, I've heard of that. An airplane which landed after 37 years and which took off long back, right? What is a gamma ray? A gamma ray is nothing but, it's a electromagnetic, it's a radioactive emission that happens when a radioactive atom undergoes decay. It is something which has very high penetrating power and can cause even damage to your DNA as well. Yeah. Which black hole is the nearest one to us? We have found only one black hole. It is called as Pobihi. It is named as Pobihi. You can actually check out the picture. It's actually a very faint picture, and that too, to take up that picture, we had to align all the telescopes in one single direction in order to get that image. So and again, it's very far away, but yeah, but it's still a definite proof that black holes do exist, right? So that's one thing that we can be happy about. Hi, Game Boy, what's up, da? Sir, I have a theory to prove time travel. Is it, Prem? Please do let me know. Please do let me know. That'll be interesting. Alright, thank you. Thanks a lot, guys. Thanks a lot. Don't worry. I'll be fine. Thank you, guys. Thank you. Yes, I've heard of it. I've heard about it, but I do not know what is the explanation for it. Like, how does an airplane take off like 37 years and land after 37 years? I still don't understand the explanation for that, but yeah. It's something that I don't know how it is possible, but yeah, it's there. Anyways, anything else, guys? Anything else? The fourth dimension. Again, see, 3 dimensions is already there. Your XYZ's length, width, and breadth is already there. The fourth dimension is sometimes it's taken as time. Fourth is the time. Sometimes if you talk about string theory, you have n number of dimensions, but generally speaking, time is the fourth dimension that we generally take. All right. Why is Area 51 kept mysterious? I have no idea. But if you talk to it's like this. I'll just tell you this, that if you talk to Donald Trump, he might tell you that aliens do exist. But if you talk to any other presidents of United States, they might tell you that it's just a army base, or is it a naval base? I think it's an army base. I think it's a Air Force base, right? It's an Air Force base, but I'm really not sure why Area 51 is kept such a it's a secret. Yeah, fourth dimension does exist. Time is another dimension. Time is something which does exist. All right. No, Shweta, I'm not. I just saw your message now. Sorry. What is diffraction of light? See the okay. Diffraction. All right. See. Uh, Diffraction is nothing but here's the thing. See, we know that light always travels in a straight line. But if you consider light as a wave, all right, as a transverse wave, as an electromagnetic wave, light can also bend around corners. All right. Again, if you consider as a wave, if you consider as a particle, it's not possible. But when you consider as a wave, light can also bend around corners of certain objects. That is what is called as diffraction of light. Again, you will be studying about this in your 12th standard. There is something called as a Young's double slit experiment. You'll be studying about all this in your 12th, so don't worry about it. Young GK helper, don't worry, you will study that. You'll actually do the experiment also in your colleges. Like if in case you actually get to college, if you get to go to college, if there's no COVID-19, then you can definitely check it out. So mini black holes existed during early. Yes, that is what I talked about as miniature black holes. Again, miniature black holes are so tiny that you can't even detect it. But according to theoretical physics, it does exist because when the Big Bang happened, it must have existed. All right. All right. Anything else, guys? Anything else? So what if you hit a black hole hits the sun? That will never happen, Sabia. But even if it does. Like I told you, if it crosses the event horizon, then yes, the sun will also get sucked into the black hole. Yeah. Tell us about dark matter. Dark matter is also a very interesting concept. Actually, I think we'll do another session on dark matter. Dark matter is one thing that I want to talk about separately. All right, we'll talk about it for sure. Yes. Yeah, Sagittarius A is also a supermassive. Again, it's not a super it's not a supermassive black hole, but definitely it's a very big, supermassive star though. All right. Anything else, guys? Thanks a lot. Thank you. Anything else? No, nothing else. No. Dark matter for sure. We'll do another session for that for sure. Don't worry. All right. All right. So yeah, I don't think anything else. No, nothing else, right? All right, people. So yeah, then that's all for today, people. That is all for today. Thank you for joining. I hope you enjoyed today's session. I hope you learned something new. Before we end, also one more information, guys. If you want to enroll into the Vedantu Pro subscription courses, the link is given in the description. These are the dates when the batches are going to be starting. The batches will be starting soon, and yes, once the batches start, then we will be doing the long-term courses. So we'll be doing every single chapter in detail, and we'll also be doing revisions of that. We'll also be having quizzes in every single session. So trust me, you'll have a lot of fun, and you'll also be learning every single topic, every single chapter in depth. So yeah, these are all the batches that is going to be starting for CBSE 9th and 10th. It's going to be on 10th of May. For ICC, it's going to be on 24th of May for 9th and 10th. For Maharashtra, it's on 24th of May again. JEE for people moving from 10th to 11th. If you want to start your JEE preparations right away, that's starting from 10th of May. And for NEET as well, it's from 10th of May. And yes, guys, the link is given in the description. The coupon code is automatically added to it. So all you have to do is click on the link, and it'll directly take you to the web page. You can choose what grade you want to target and which board you guys do are in. So once you select that, all the details will be given right there and then. And yes, the coupon code is automatically applied. You get a 10% discount on that as well. And yes, that's pretty much it. Do not forget to like, share and subscribe. Thanks a lot for joining today's session. And yes, guys, whatever other doubts you have, if I've missed out any, I'm very, very sorry for that. Please send me an email of that. I'll definitely try to take some time and answer it. And please expect a delay. Like I told you, I don't feel that great these days. So whenever I do feel a little better, for sure you can expect even though it's a little late, it will happen. Later vandalum, latest hour way. It's like that. All right, even if it is late, it'll definitely help you. I'll definitely try my best to answer your emails. All right, so yeah, guys, that's all for today then. Thank you for joining. A fish rain. All right. Okay, anyways, guys, so that's it then. Sir, what if there are two suns in our solar system and both turn into a black hole? That the possibility of that is very, very minuscule now. Possibility of that is very, very minuscule. All right, but anyways, twin stars do exist, but not theoretically. I mean, a massive twin star. It's something that we have to wait and watch. Anyways, thank you, people. That's all for today then. Take care of yourselves. Do not forget to like, share, and subscribe. I'll see you guys soon. Sure, David. I will. Don't worry. All right, just send me an email. Just send me an email. I know that it's I'm delaying it, but I'll definitely reply to. Just little time, and I'll definitely reply. All right. So yeah, guys, take care. Bye bye. See you all. See you soon. Enjoy yourselves. I hope you enjoyed it too. Take care. Do not forget to share, like, subscribe. Bye bye.